Hey everyone, and welcome. In this course, we'll explore how data analytics can be used in the insurance industry. When it comes to data analytics, methodologies and overall workflows are often similar across domains. However, each domain requires specific knowledge and products. So it's essential to learn data analytics tailored to each domain. And in this lecture, we'll dive into analyzing insurance related data. Specifically, we'll focus on optimizing insurance portfolios, developing effective analytic strategies, and enabling you to play a crucial role in the company's decision making process. This course is all about tuning raw data into actionable insights through analytics, machine learning, and interactive dashboards. Now, let me tell you a bit about myself before we dive in. My name's Henry, and I hold a bachelor's degree in economics and business analytics. My journey began with econometrics in economics, and I found data analytics to be very exciting. I even got to be a teaching assistant during my studies, which inspired me to pursue a master's degree in analytics. And now, I'm a data scientist with over 6 years of experience working across various domains, including insurance, bioscience, and energy. And for this course, we'll focus specifically on the insurance domain and learn how data analytics can make a tangible impact. Now let's begin by discussing what you can learn and what you can gain from this course. This course is structured around three different pillars. First, getting started with insurance. We'll begin by understanding insurance data and conducting basic analyses such as visualization and simple statistical methods. This will help us grasp what insurance data entails and build a foundational understanding. The focus here lies in the insurance rather than data. This is because without insurance data, even the best analyses can fall flat. So I'll emphasize this again throughout the course, but knowing the domain and aligning with domain experts is crucial. So simply running data through models or analytics tools isn't enough. You need to connect the data with domain knowledge to provide relevant insights. Next one is advanced data analytics. We'll dive deeper into the data and advanced analytics part. This involves starting with clear business hypotheses to guide our analysis. And when we analyze data, we don't just analyze the visible columns or approach it however we like. When conducting analyses, there must be a clear direction and a storyline we want to convey. And in this section of the course, we'll be able to answer questions such as how do we establish a business oriented storyline? Or how do we present insights to our target audience, whether they are practitioners, or team leaders? A strong hypothesis sets clear objectives and aligns with business goals, so it ensures the analysis to stay focused and relevant. On top of that, we'll discuss how to automate parts of this process so that we could target efficiency and scalability. And the last pillar is Power BI dashboards. We'll learn how to communicate our findings effectively by building interactive Power BI dashboards. A dashboard isn't just about displaying data. It's about telling a story that empowers decision makers like executives, team leaders, and practitioners. You'll learn how to structure dashboards, optimize data for Power BI, and also tailor them to different audiences. Now, let me go one level deeper and explain what we'll be learning in each of these three parts of the course. The first step, as mentioned, is to understand the insurance data and conduct basic analyses. It's important to understand the insurance domain because it helps us set the domain for our analysis. It also allows us to communicate with practitioners and find out what they are actually curious about. Also, they already have many insights from years of experience, and our role is to provide them something meaningful. So, and this sometimes can be very challenging. The insights that we provide should add value to their years of accumulated knowledge, and sometimes we need to know more than what the practitioners actually know. So, understanding domain knowledge helps us set the direction of our analysis. And the second part we'll learn is defining the business problem. Starting with a clear business question saves time and resource. Imagine imagine realizing halfway through our analysis that your target isn't actually aligned with what the client actually cares about. So starting with a well-defined problem avoids this kind of issue. And in real scenarios, we often work with limited time and resources, so it's crucial to set the right direction from the start. The third thing we'll learn is basic data preprocessing. We'll use Python to do some basic preprocessing and also automate some of these processes so we can apply this to other data sets. And lastly, we'll design the overall data analysis strategy. By understanding the overall domain knowledge and what our objective is, then we can start actually delving into the data part. So the second pillar of our course is advanced data analytics. Now we are equipped with domain knowledge and clean data, so we are ready to dive into advanced data analytics. So first, we'll establish a very simple foundational hypotheses based on intuitive business questions. These hypotheses guide our way. These hypotheses guide our analysis and evolve into more complex one as we gain deeper insights. These hypotheses guide our analysis and evolve into more complex ones as we go deeper into our data. I'll share three principles for crafting effective hypotheses that could deliver real business value. These three tips are extracted from various hypotheses I have seen so far, and it is the core of a powerful These three tips are extracted from various hypotheses I have seen so far, and it is the core of a powerful hypothesis that actually bring impact. Next, we'll test these hypotheses using statistical methods, such as multi-factor analysis, or use other advanced tools like machine learning. This step allows us to uncover deeper insights and even automate parts of the analysis for future use. So, lastly, a solid data analysis strategy is essential since it ensures you to stay focused and avoid getting lost in the middle. Sometimes you can go too deep into the rabbit hole and lose track of what we are trying to do during the process. A solid strategy would be able to set milestones along the way so that we don't get lost. The last pillar is Power BI dashboards. After completing the analysis, we need to present the results effectively. While it's possible to provide the results in a report format, there are cases where we need to allow users to interactively experience our findings. So, dashboards are powerful tools to communicating complex results in a way that is easy for the clients and decision makers to understand. For this, we'll use Power BI. So, it's a tool from Microsoft that works well on Windows, and we'll start by preparing the data and converting it into a format optimal for Power BI. It involves linking multiple tables and creating interactive elements. And this is because each visualization should connect seamlessly to build a comprehensive story. However, we should bear in mind that dashboards vary. However, we should bear in mind that there should be different dashboards depending on the user. I'll guide you step by step through designing dashboards tailored to each different audiences, such as executives, team leaders, or practitioners. So by the end, you will be able to create dashboards that not only present data, but also drive business decisions. So by the end, you'll be able to create dashboards that not only present data, but also drive business decisions. This course is more than just technical skills. It's about creating real impact. You learn how to combine domain knowledge, advanced analytics, and effective communication to provide insights that truly matter. Whether you're new to data analytics or looking to specialize in insurance, this course will equip you with the skills and strategies to succeed. And now, let's get started. Now that you've decided to learn data analytics, we'll begin by introducing the project we plan to work on. I'll give you a broad overview, discuss the type of analysis we'll be doing, and set goals for what we aim to achieve by the end of this course. Now, you might wonder why we're starting with this instead of jumping straight into the data. The answer is simple. Business goals come first. Sure, data is crucial, but it's only valuable if it aligns with the bigger picture. Data analysis exists to create value, and that value needs to be tied to the business. Beginners often focus on the data itself, but experienced analysts know better. They start by asking, what can the what can this analysis actually do? And is it feasible from a business standpoint? That's the approach we're taking here, beginning with the business context before diving into the data. Let me explain this a bit further. Before launching any project, there's typically a POC, proof of concept phase, for some sort of feasibility assessment. And during this step, the first thing to check is whether the project is even necessary. If it is, we then measure its potential impact. Only after that do we start reviewing the data to determine if the project can realistically be executed. So it makes sense to understand the business requirements of a project before getting our hands dirty. Let's start by understanding the big picture from a business perspective. So for this session, I'll use an insurance company as an example. Like any business, insurance companies have two main goals: increasing revenue and reducing costs. So every company strives to maximize profit, and insurance companies are no different. On the revenue side, insurers typically focus on three areas: marketing, investment, and product diversification. Marketing efforts can range from traditional ads to promotional campaigns, like offering lower premiums or launching limited time products. Investments are another key source of revenue, and insurance companies invest the premiums they collect to generate returns, which is which is essentially critical for life insurance providers. Then there's product development. Back in the day, insurance options were pretty straightforward: fire insurance, auto insurance, and so on. But now, there is a growing demand for more niche products like pet insurance, scooter insurance, and even drone insurance. And as technology evolves, insurance companies need to keep up by creating products for emerging needs. Now, while increasing revenue is important, cutting costs is also critical. This is where the loss ratio comes into play. The loss ratio measures how much insurers pay out in claims compared to the premiums they collect. For example, insurance companies would collect premiums from its customers, and for auto insurance, payouts for car accidents would contribute to the loss ratio. For homeowners insurance, it could be claims for fire damage. From the insurance company's perspective, these payouts are losses, especially when they exceed the premiums they collected, which leads to a higher loss ratio. So, reducing this loss ratio is a key priority for insurers. And one way they manage this is through reinsurance. Think of reinsurance as insurance for insurance companies. Just like individuals buying insurance to prepare for unexpected events, insurance companies buy reinsurance to protect themselves against large payouts. Let's consider an example. Imagine there's a massive building in LA, and for some reason, perhaps a fire, the insurance company has to pay out a claim. These types of payouts can often reach tens or even hundreds of millions of dollars. For an insurance company, such a large payout in one go can be a significant financial burden. And to hedge against these risks, insurers assess the risk associated with such as assets or policies and purchase reinsurance accordingly. Reinsurance essentially helps them set a bottom line for their loss ratio, and in other words, they decide this is the maximum loss we're willing to take. Beyond this point, we are going to rely on reinsurance to cover the rest. Now, when it comes to policyholders, insurance companies aim to attract good policyholders. For example, if someone has been in 5 different car accidents in the past, it's pretty reasonable for the insurer to predict a higher likelihood of future accidents. These riskier policyholders increase the likelihood of claims, so selecting better policyholders can help reduce the loss ratio. Another significant factor in impacting cost is insurance fraud. Fraud can occur in all sectors from life insurance to property and casualty insurance, including auto insurance. Insurers invest substantial effort in reducing unnecessary costs caused by any fraudulent claims. And this leads to a balancing act. On one side, insurers want to expand their market by offering a wide variety of products and marketing them aggressively. On the other side, broadening the customer base too much can also invite higher risk individuals, leading to increased costs and higher loss ratios. So, this is where portfolio optimization comes into play. At times, the focus is on increasing revenue by expanding the market, while in other cycles, the emphasis shifts to reducing costs for greater profitability. So, for this project, while we're not directly optimizing portfolios, we'll focus on something equally critical: insurance fraud detection. From an insurer's perspective, it's impossible to investigate every claim to determine if it's a fraudulent claim or not. The sheer volume of claims makes this whole process impractical, and there's often not enough manpower to handle such a task. They should focus on doing other tasks, something that has more business value. And more importantly, investigating small claims might not be cost effective. As an example, if a fraudulent claim requires a payout of $100 but costs maybe $500 to investigate, it's clearly a loss for the company. This is why insurers tend to focus their fraud investigations on larger claims, leaving many smaller cases unchecked due to resource constraints. So currently, only about 1 or 2% of claims are thoroughly reviewed for fraud. For example, out of 200 claims, only two might undergo a detailed fraud investigation. So you can see that there's plenty of room to decrease potential loss if we review more claims. And this is where data analysis and automation can make a difference. Once an analysis or machine learning model is set up, it can process claims quickly and at a much lower cost. For example, by applying predefined rules or algorithms, the system could flag claims that have a higher likelihood of being a fraudulent claim. And this prioritizations enables fraud investigators to focus on the most suspicious cases, allowing them to review more claims in less time. And as a result, the cost of fraud investigation per claim decreases significantly, potentially cutting costs from $500 per claim to $250 or even $100. So for insurers, this means resources are used more efficiently and automation can gradually be refined to handle even greater volume of claims. So in this project, we'll use data analysis and machine learning to build an automated fraud detecting pipeline. So now that we went through all these insurance domain knowledge, we have a clear understanding of our goals. And you can see it on the top right corner of this page. First, identifying factors associated with fraudulent claims. Second, predicting the likelihood of fraud in future claims. And third, developing rule-based systems for fraud detection. And for demonstration purpose, let's assume we received this data set from a data engineer. Actually, the data set we'll work on is from Kaggle, and it's labeled as the vehicle insurance claim prediction dataset. Starting in the next session, we'll dive deeper into the analysis and begin building our models. See you in the next chapter. Hi, welcome back. We'll pick up from where we left off in the last video and start visualizing our first plot, which is a histogram. As mentioned before, we're going to use Plotly histogram to visualize our histogram. So in order to do that, we should put in some values to the parameter. And one of the parameter would be df, which is the data frame that we currently have. And the other one would be the column name of the axis. So here, since it's a histogram, we should put in numerical columns. And to do that, we could use info, which is a function that was mentioned in the previous video, and it would provide the data type of each column. So columns that are numerical would be week of month, um, week of month claimed, age, fraud found, rep number, policy number, deductible, driver rating, etc. So age is a numerical column. So let's try it out. So this is the histogram of our age column. You can see that it ranges from 0 to 80. And here also you can see that it's pretty weird. So no one is 0 years old. And you can definitely see that there's an odd number here. And as mentioned before, and these numbers are actually values that were null values in the first place. And besides that, you can see age ranges from 16, a lot of people around 20s or 30s. We also have people in their 40s or 50s, also 60s, and it goes way up to 80. And we can plot other columns as well. As an example, we can see fraud found, and if we plot it, we can see that a lot of claims are non-fraudulent claims, and only a small portion of them are fraudulent claims. Only 923 of them are fraudulent. So, so we can plot all these columns like this, but plotting them individually one by one in a code like this would be very inefficient. So in order to make it more efficient, we want to make it into a function. Let's see, and the function name would be plot histogram. And when creating a function, we need to specify the input parameters. And for input parameters, those will be the ones that changes every time. So here in our case, it would be the type of data frame, the X column name, and the title. So we could put in these different um, parameter names in our function. So we can start off with data and then xcall and then title. So we can just copy this and paste this inside our function and specify the data and the X column name and the title like this. And it will return this figure. So if we execute this function, it would look like this. And one thing different from just executing the raw code here is that after executing this function, you store this figure, this visualization into this fig object. So after you need to actually execute or execute fig.show in order to see the visualization. Just just executing the function won't do anything. Now we have half automated our histogram. The next would be to visualize our count plot. So count plots are pretty similar to histograms, but those are used for um, categorical values. So, however, in Plotly, you can use the same thing because the underlying way of visualizing a count plot and a histogram is pretty similar. A histogram is actually a count plot for numerical values, and a count plot is just another name for histograms, but it is for categorical values. It counts the number of certain levels or categories happening inside that data set. So the same thing goes here too. We're going to plot the Marshall status, and that's why we're putting Marshall status column name in the X axis here. And you can see that some are single, 4,000 singles, um, 10K married. We also have widow and divorced. And another thing that we could do for count plots is that we could order the x-axis as we like. So right now it starts with single, and then married, and then widow, and then divorced. But maybe you want to order it by count. Maybe you want married to be on the first column and single to be on the second one because there are more married people than single people. So in order to do that, we have to put in another parameter inside this function. And then that extra parameter will be category orders. And we have category order, Marshall status, and we don't want to hard code all these things. So we can use the counts to order. I'll show you how it's done specifically. We could go Marshall status, value counts index. Yes, this is correct. So let's break this down one by one. So the additional parameter that we are putting in is called category order, and we want to order Marshall status, which is the X value here. And these code will indicate how we want to order our Marshall status. So if we execute this code, we can see that it first starts with married, single, divorced, and then widow. And this is done like this because if we execute value counts, it will count the number of instance for every unique value inside that column. So for Marshall status, we have 4 different levels, and for for each category, we have married over 10K, single 4,000, and it is automatically sorted um, in descending order. And retrieve these indices, we set dot index to get the index text. So after we get this list of text, we just put it inside the dictionary so that for Marshall status, it will be ordered from this kind of order that we set. And same for the count plot. We can automate this by making it into a plot. So let's just copy this one. And then when we define a function, the same thing applies here too. We need to specify the input parameters. So we will want to put in data, We want to put in X column as mentioned before, and also the title. And then the difference here would be these things will be the same, and the title goes here, and this category order would be different. So for the name, we should put in X columns, and the same thing goes here too. For data and X column value counts dot index, and we will return the figure as we did in the previous function. So if we use this plot count plot, df, um, let's choose a different column this time. Let's look into our data set again. And since it's a categorical one, maybe we could look into policy type. So policy type and title, we'll just leave it blank there. And you can see that it orders the different policy type according to its count. We have a lot of sedan collision coverages, and then another sedan, and then another sedan. So a lot of coverages, a lot of claims and products are related to sedan vehicles, and then it would be sports cars or utility. Great. And now we have automated two main parts of the histogram, two main parts such as histogram and count plots. And now we want to automate this a bit more further. Um, we want to create a function that would allow us to plot the whole data set. So the function name would be plot data frame. And if we put in a data frame, we want this to plot the whole num every column available inside this data frame and plot it for us so that we could just skim through and take a look. And in order to do that, we first need to identify whether each column is a numerical column or if it's a categorical column. As mentioned before, we could use df.info. It provides us with all the data types, but there are other ways. One way is to use the pandas package that we imported. And I've been looking around the documentation and found a good function that we can use. So if we look at the available functions that we can use inside PD, API, and types, we see is numeric D type, is object D type, is period D type. So basically, there are functions inside this types that allows us to determine whether the input value is a certain data type or not. So we can use here is numeric type and is object D type in order to determine the types of the column. So if we test this is numeric D type, and if we put in df.age, we know that age is a numerical column. And if we change this to object D type, we get a false because it's a numerical value and we want it's a numerical value. So using these two functions, we can now iterate through the columns and determine its data type. And after determining its data type, we can map those columns to the right function that we created before. So we have plot count plot, and then we have plot histogram. So we're going to take these two functions and put it inside this plot data frame, and then start building our code from here. So we want to iterate the columns. So for call in df.columns, if we execute df.columns, it will provide us with all the columns inside this data frame. And if, exactly, so if the API type is numeric, and if it's numerical, we want to use this plot histogram function. So this would be executed, and the title should be maybe we can just put in the column name as the title. So, and if it is an object, we would use the count plot. And for count plot, the input parameters will be the same. And here, we also want to get all the figures. So we first want to create a list so that we could append all the created plots and figures into this list. So after iterating inside the if loop, then we could append all the figures to this list and return the list in the end so that we could see how it goes. I forgot to put in the input parameter here. And now let's give it a try. We have plot, data frame, and we input our data frame like this. And then the output would be the individual figures. So I've returned a figure list. And as mentioned before, we need to execute um, fig.show in order to actually show the visualizations. So I would first sort them in a figs object and loop all these figures in figs, and then I would just put in fig.show in order to show all the plots. So let's quickly skim through all of these and take a quick look at our data set. So for month, we have January, May, March, June, October, August. We have a lot of claims in January and in May. And for a week of month, a lot of claims come from the 3rd. However, they don't differ that much. Day of week, a lot of claims on Monday, not much on Sundays. We have a lot of Toyota or Honda cars. And accident area would be urban. Um, Day of week claimed Monday, month claimed. A lot of male drivers, a lot of married drivers. Age, we looked at this before. Um, Policyholders, the ones usually held in responsible for the accident. Policy type, a lot of sedans. Vehicle category, as we can infer from this coverage type, there are a lot of sedan cars. For vehicle price, a lot of cars are in between 20K to 29K. Fraud, policy number, I don't think this would be relevant in our analysis. Also, rep number is not relevant because it's a unique identifier for each policy. But we're going to use statistical methods or aggregate all these numbers, so we don't actually need unique identifiers here unless we want to view each and individual claim. We also have deductibles. It's interesting because we have a lot of claims that has deductible 400. We also have driver rating. And by looking at this, we could also kind of infer that driving rating would not be a um, major differentiator for us to use in order to um, come up with whether it's a fraud or not. Because in order for a column or a data set to be um, meaningful in a data point of view, it has to have differentiating characteristics. But here, as you can see, um, the driver rating for all levels have similar counts. We can see that it's pretty evenly distributed. And then we have days policy accident. days policy claim, past number of claims. A lot of people don't have past claims, but there are also a lot of people who has 2 to 4 claims in the past. Age of vehicles, more than 7 years or 7 years. Age of policyholder, police report filed. You can see that not a lot of there are not a lot of claims that has police report, and even less claims that has a witness. Agent type, number of supplements, address change claims, number of cars, year, and base policy. So this base policy is also important because you can see the different types of coverages here. And based on the different type of product, the characteristic of drivers or characteristics of fraudulent claims um, would differ a lot. Now that we know how our data looks like, the final step would be to store our functions in a separate file so that we can utilize them in other situations too. So if you look at the code block here, I'm importing some functions from this thing called utils. And this is actually a Python file stored in the same directory of my notebook, and it has all the functions that we defined before. So we have count plot, and then histogram, and then we also have plot data frame. And if you look into the code, and it's all similar to the code that we coded together. So let's have it a try. So we import the function, and then we can see that if we type in help, it provides a basic information about this function. And if you remember, the reason we can see these kind of instructions is because we provided docstrings to this function. And this docstring is actually provided by me. This plot count plot, this plot count plot from is defined here. And you can see there's a doc string here. And this is what you actually see if you type in help. And it's really important to document all these because once you code a certain function or anything, after of after weeks or days, or even for other people, it's really hard to remember what this code actually meant. So it will take you longer if you don't put in documents like this, and because you'll have to start from scratch, or go backwards to infer what kind of parameter you need to put into each function. So using these doc strings, you can specify what kind of parameters you need to put in, and the type of each parameter. As an example, this df has to be a data frame, and column name has to be a string, and also you could specify what it returns. So here I said that I wrote down that it returns a plotly graph. And by looking at all these, you can always come back to this and easily put in the parameters that's necessary to activate each function. So let's take a look at the first one, which is plotting a count plot. You put in the data frame and the column name, and it creates a count plot for you. And we could also check out plot histogram. And in this case, it would be age. And then you can see it like this. And the ultimate function that we want is plot data frame. So this would create plots for all your columns, and you can see that every column was visualized like this. And that wraps up to our overview of the data. And in the next session, since we now have a grasp of the data set, we'll explore domain knowledge in a more depth, um, specifically insurance as an industry. To draw meaningful insights, we need to understand how insurance products work. We can compare the coverages between liability and collision, or we could also delve into the characteristic of deductibles and so on. And we'll dive into those details and start formulating hypotheses for our analysis in the upcoming lecture. That's all for now, and see you in the next session.